Okay, so number 21 on page 465 is log base 2 of x plus 7 plus log base 2 of x plus 8 equals 1. So the directions say solve each logarithmic equation, express irrational solutions in exact form, and as a decimal rounded to 3 decimal places. All right, so this one, what do you notice? When you're solving equations, you're going to want to simplify each side as much as possible first, and then you can think about the inverses of the logarithms or exponential functions. So these are both log, on the left side of the equation here, these are both log base 2. And they're added together. So how can I rewrite that? Good. Log base 2 of using the product property of logarithms, I can write that as that first argument, x plus 7, times the second argument, x plus 8. As the argument of the logarithm of the same base, 2, equals 1. All right, so now that's a single logarithm. So if I have a single logarithm equals another single logarithm or equals a number, now I can think about the inverse of that logarithmic, or that logarithm of base 2 is what? What's the inverse of log base 2? Exponential function with base 2. So it's going to be 2 to that power log base 2 of x plus 7 times x plus 8 equals 2 to the first power. So I raise both sides up as exponents with the base of 2. So you have to make sure and do both sides. You can't do that just to one side.
2 to the power why is it 2 to the power 1 on my side?
Because this is the exponent on this side, and the 1 is the exponent over here. They're both raised to the same power, or with the same base. They're both raised up as exponents of the same base. Because remember, if the bases are the same, then we can say the exponents are the same. And also, if these are the same, we can raise them up as exponents as long as the bases are the same. So we use the 2 because of this base here being 2. And the reason that we wanted to do that is because exponential function with base of 2 and logarithmic function of base of 2 are inverse functions. So they undo each other, leaving me just with x plus 7 times x plus 8 on the left side of the equation, and then 2 to the first power is just 2. So now we can go ahead and multiply these out. We get x squared, and then x times 8 is 8x, 7 times x is 7x, plus 56, 7 times 8, equals 2. So what kind of equation is that now? Quadratic. So once you know it's quadratic, you want to get one side equal to 0. So x squared, 8x plus 7x is 15x, minus 54 equals 0. Oh, thank you, plus 54. Okay, so then does that factor? Since there's a 1 in front, is there anything that multiplies together to give me 54 and adds together to give me 15?
6 and 9.
6 and 9. So it's going to be x plus 6 and x plus 9 equals 0. So then set each factor equal to 0. So x plus 6 equals 0, or x plus 9 equals 0. And then solve for x, so x equals -6 or x equals negative 9. Now, before we can say that these are in fact answers, we need to think about plugging them back in up here. And this is always true for any logarithmic equation. So when you have an equation that has logarithms in them, what is the restriction on the domain there? What do these arguments always have to be? They can't be equal to 0, they can't be negative, so they always have to be positive. The arguments always have to be positive. So if I put a negative 6 in up here for x, is the first argument x plus 7, is that going to stay positive?
Yes.
Yes. If I put negative 6 in for x plus 8 in that second term, is that argument going to stay positive?
Yes.
Yes. So x equals negative 6 will work. What about negative 9?
No.
No, because if I take negative 9 and plug it into that first argument, negative 9 plus 7 is going to leave me with a negative in that argument. So that's not going to work. So the only solution is going to be x equals negative 6. So anytime you're solving an equation that has a logarithmic term in it, make sure that you check your answer to see if it's going to make that argument negative or not. If it does make that argument negative, then that solution is an extraneous solution. It won't work. Yes?
Is there ever a situation in which both of them would make the
Yes. So if they both make it negative, then you would say no solution. Okay? All right. Good question. Any other questions on that one? Okay. Look at number 41. So number 41 on page 465.